purpose that we discuss here only for chemistry purpose. In chemistry subject, for discussion of the behavior of chemical compounds, what are the units we require, that we discuss here. First, before to know the behavior of chemical substances, to know the behavior of chemical substances, to know the behavior of chemical substances, chemical substances, to know the behavior of chemical substances, two types of properties we require. Two types of properties we require to know the behavior of chemical substances. That two types of properties are, two types of properties are required. Two types of properties are required to know the behavior of chemical substances. We require two types of properties. One is chemical properties, chemical properties, and physical properties. Chemical properties and physical properties. We need these two types of properties to know the behavior of chemical substances. Whatever the chemical substance, to know its behavior, we must know chemical properties as well as physical properties. The measurement of chemical properties is nothing but the measurement of chemical properties. Measurement of chemical properties. I'm writing this shortcut, chemical properties. The measurement of chemical properties involve chemical reactions. Involve chemical reaction means based on the chemical reactions we can measure the chemical properties of a substance. We can measure chemical properties of a substance based on the chemical reactions, whereas the physical properties cannot be determined by chemical reactions. Physical properties cannot be measured, cannot be determined by chemical reactions. Only chemical properties can be measured by using chemical reactions. To measure the physical properties, we require some physical properties required, like mass, number one, number two, length, we can also call it as size, number three, temperature. Physical properties, I'm saying physical properties of a substance are mass, length, temperature, time. Number four, time. I'm sorry, time. Number five, volume. Size here also will come because volume is three-dimensional, length is one-dimensional. So size, volume, time, and density. Sixth one, density. These are the physical properties. These are physical properties. Among these, mass, time, temperature, mass, length and time, sorry, mass, length and time, this one, this one, this one are called, these three are called fundamental properties. First we should know these are the basics. This is basics. You should know what is that. So 6 properties, physical, like there's so many properties are there. I'm writing 6 properties in this. 1, 2, 4. Mass, length, time are called fundamental physical quantities or fundamental physical properties. Fundamental physical quantities are, we can also call as properties, fundamental. So mass, what is the meaning of mass? It tells about the quantity of. So let me discuss one by one. First, what is mass? What it tells, what it says means, mass says the quantity of matter. It says quantity of matter, because chemistry is study of matter na. So to know the quantity of matter, we require one of the fundamental physical quantity, that is called mass. Mass nothing but it tells about or it describes about the quantity of matter. So it will be determined by using analytical balance. Analytical balance means weighing, kilogram, gram, milligram, like that. So that is units, and this mass is one of the property. And remember, the mass of substance is constant. Mass of substance is constant. Mass of substance is constant, but weight of substance is not constant. Mass of substance is constant, but weight of substance is not constant. It will be changed by the change of place, we can say. For example, it depends upon the gravity. Why it is not constant means it depends upon gravity. Depends upon gravity. Gravity depends on gravity. Weight depends on gravity. Mass depends on quantity of the matter. It never depends on the gravity. Suppose 100 grams mass is there on the earth, the mass will be 100, but and weight will be 100. But same matter, if it is present on the moon, its gravity is different. So 100 grams of mass becomes 16.8 grams of weight, because its gravity is 16.8 grams per cc, like that will be the density. So that gravity, mass gravity, earth gravity is different, moon gravity is different, sun gravity is there different, like that. Means the 100 grams of matter on earth, the weight is 100 grams on the earth, but the same matter on the moon, it becomes 16.8 grams, not 100 grams, but mass will be 100 grams itself. Mass will be 100 grams on earth as well as on the moon, but weight is 100 grams on the earth and 16.8 or around approximate is grams weight will be on the earth. The same matter, same 100 grams mass matter, if it is present on the sun, let me consider, if it is present on the sun, its weight becomes 250 grams. 100 grams mass, but weight is 250 grams. Means if you take 100 grams mass substance on the earth, the weight will be 100 grams, mass will be 100 grams. But same matter, same 100 grams mass matter is present on the moon, mass will be 100 grams, but weight will be 16.8 grams, because gravity will be changed, pulling tendency. And the same matter, 100 grams of mass matter is present on the sun. So the mass will be 100 grams, but weight will be 250 grams, because its density is, its gravity is 250 grams, like that will be there. So weight will be changed based on the gravity, but mass will not be changed. So mass is constant for the substance, but weight is not constant for the substance. Mass is constant, but weight is not constant. Mass does not depends on the gravity. It only describes the quantity of matter, whereas the weight depends on the gravity. So, depending upon the gravitational force, the weight will be changed. So, that is one of the fundamental physical property must and should we should know to understand the basics in chemistry. Okay, the next property is size or length, we can say. Size and length, second fundamental physical quantity. There are three fundamental physical quantities are there. I told you that is one is mass, one is length, another one is time. So second one is, this is first one, and coming to second one, that is length. It describes what? Length describes size, we can say. So the object is made, the size of object. Length means the size of object or substance, you can say. That object you can say here as substance. The size of object is measured in terms of length. Is measured in terms of length, area, and volume. Length, area, and volume. The size of substance is measured in length, area, volume. Length is the size of object in one dimension. Area is size of the object in two dimensions, that is 1D, this is 2D, and volume is nothing but the size of object or size of the substance in a three dimensions. Length is one dimensional measurement of size. Area is two-dimensional measurement of the object or substance. Volume is three-dimensional measurement of the size of the substance. One-dimensional is length, two-dimensional is area, three-dimensional measurement of size of substance or object is called volume. So this is length. Second one, second fundamental quantity is length, that is size of the substance in one dimension. In two-dimensional, x-axis, y-axis, if you take, that is called area, that is size of the object in two-dimensional. X, y, z axis, if you take, volume, that is the size of object in three dimensions. So three-dimensional of space is called volume, two-dimensional of space is called area, one-dimensional space occupied by the substance or object is called length. So this is second fundamental physical quantity. Next, third fundamental physical quantity is time. It is time. One of the I already told you three fundamental physical quantities are there, physical properties. One is mass, second one is length, third one is time. So mass I told here, weight is different, mass is different. Length, the size of object is measured in length in one dimensional, area in two dimensional. And coming to time, it helps to know how long it takes for a process to occur. It means it measures how long it takes a process a process to occur, to take place a process. How long it takes is nothing but time. That is third fundamental physical quantity. So these are three fundamental physical quantities. After that, let me see the basic units of measurements. Basic units of measurements. Basic units. These three, once again, please be pause the video and write it down on the notes. You will get complete idea about the physical quantities and their SI units. Seven basic units of measurements are there. There are seven seven basic units of seven basic units of measurements are there in physical quantities and physical properties. Seven basic units of measurements are there in physical quantities. Once again, I'm remembering to know the behavior of a chemical substances, we should know chemical properties, we should know physical properties. Chemical properties can be measured based on the chemical reactions. Physical properties can be measured only based on the physical quantities and their units. In that, I told you some properties in that three fundamental physical quantities I explained, that is, one is mass, length, time. Now let's come to the next thing, physical quantities. Seven basic units of measurements are used in a physical quantities measurements. Physical quantities measurements will be done by seven basic units. They are mass. The first one is mass. Second one is length, just now I told you. Third one is time. Fourth one is, first these three, next fourth one is temperature. Temperature. And fifth one is electric current. Please be concentrate so you will understand the basics of chemistry. If you are not understanding all these things, it is not possible to understand the basics, and further chemistry topics becomes difficult if you are not understanding all these things. They looks like very simple but not very simple. Next one is luminous intensity. Sixth one is luminous intensity. Luminous intensity. And seventh one is, the last one, seventh one is amount of substance. Amount of substance. I'm not saying other things. Amount, mass is different, amount is different. Amount of substance. Amount of substance. So these are called fundamental basic units to know the physical properties of a substance. Seven basic units. Seven basic fundamental measurements. These are the fundamental measurements used to describe the physical properties of the substance. In that, already we have discussed about these three: what is mass, what is length, and what is time. Let's discuss about temperature. Let me discuss about fourth one is temperature. Temperature is the temperature. Temperature means the amount of heat. Amount of heat we know already, it is one of the physical measurement. So it will be measured by three types of units. One is Celsius, or we can say it as centigrade. Celsius or centigrade, first one. Second one is Kelvin. Third one is Fahrenheit, degrees of Fahrenheit, degrees of Celsius also we can say. It is called Fahrenheit, 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 foreign, Fahrenheit, Fahrenheit. So it's represented by degree of C. It is represented just by K. We should not write degree, and it is degree of Fahrenheit, F. Centigrade will be measured degree of C, and Kelvin just measured in a K, and Fahrenheit will be measured in a degree of F. The relation between Kelvin and centigrade is 1 and 3 relation. If you take 1 and 3 relation means Celsius or centigrade, and sorry 2, 1 and 2 relation, let me see first, then let's go for next one. 1 and 2, if you take Celsius or centigrade and Kelvin, 1 Kelvin equal to 1 Kelvin equal to degree centigrade, 1 degree centigrade, Kelvin equal to degree centigrade plus 273.15 plus 273.15 you have to add. So Kelvin equal to, if the temperature is measured in Kelvin, compulsory temperature must be taken in a Kelvin only for numerical calculations, even though if he has given in degree centigrade. Why? Because we should not take temperature as degree centigrade units for calculations. If you do like that, you will get the wrong answer. So compulsory temperature must be in Kelvin, whether he has given in Fahrenheit or centigrade or Kelvin. Whatever the units he has given, first you have to convert that into kelvins. If he has given directly in kelvins, no need to convert. But if he has given in degrees, and mostly will give in degree centigrade, so must and should you have to convert into kelvin by using this one, degree centigrade plus 273.15 you have to take. And if you take centigrade and Fahrenheit, 1 and 3, 1 and 2 relation, it is coming to 1 and 3 relation. If you take 1 and 3 relation, if you take 1 and 3 relation means relation between centigrade and Fahrenheit. 1 degree centigrade, degree centigrade equal to, degree centigrade equal to 5 by 9, 5 by 9 into degree of Fahrenheit plus 32 you have to take. So minus 32 you have to take. Minus 30 degree Fahrenheit, 5 by 9. Degree centigrade equal to 5 by 9 into degree Fahrenheit minus 32. This is the formula you have to use to convert Fahrenheit into centigrade. And Fahrenheit, so centigrade into Fahrenheit, by you can convert like this: degree of Fahrenheit equal to 9 by 5. 5 by 9 becomes 9 by 5 into degree centigrade plus 32. That minus becomes plus. So to convert Fahrenheit into centigrade, this is the formula. To convert centigrade into Fahrenheit, this is the formula. To convert centigrade into Kelvin, is this is the formula. So whatever the he has taken, whatever the units he has given to calculate or to do the numerical calculation, temperature must and should be in a kelvins only. So whether he has given in Celsius or kelvins or Fahrenheit, calculation purpose you have to convert temperature units must and should into kelvin. So this is the relation between degree centigrade and Fahrenheit. To convert Fahrenheit into centigrade, you have to use this one. To convert centigrade into Fahrenheit, you have to use this one. So these are the three formulas. This is fourth basic fundamental physical unit. Fourth basic fundamental. Remaining electric current, luminous intensity, amount of substance, let me discuss later. Now these are basic units. Next, let's go for derived units in the next video. Okay, in next video, these 7 basic units we have completed: mass, length, time, temperature we have completed here. Remaining 3 not required for right now in the basics in chemistry, that will be there in physics as well as in further also in the coming topics. That units discussion about these units will become, mostly these will come in physics, so not required for us. That's why I'm not going to discuss here. Up to 4 only we require. That's why I'm explaining: mass, length, time, temperature. These four required. How to convert that thing we have seen. Now in the next video, let me see derived units, physical quantities only I am saying, not chemical quantities. Chemical properties of substance they can be determined by using chemical reactions, but physical properties of substance can be derived by using, can be measured by using physical quantities. Basic physical quantities and their units are this. Thank you.